Hello everyone and welcome back to my channel. In today's lesson we're going to practice with quadratic functions. A quadratic function has a form and we will talk about today. It is standard form of quadratic function we was talk about previously. And the graph of quadratic function is U-shaped and called parabola. As you recognize, that is graph of quadratic function, and the shape of this graph named parabola. So we're going to outline steps we need to find out and take in terms of quadratic function. And the first step, always we can find that point. It's called vertex of parabola. To find vertex of parabola, it has two coordinates, x and y. To find x coordinate of the vertex, we applying this formula, negative b over 2a. To find y, we will practice, we just plug in that value to original equation. We will practice with that. But what is important, that formula you can find, you need to remember that x coordinate. And also it is the same formula, it is vertical line, it's line of symmetry. So parabola symmetrical over the line of symmetry, and line of symmetry, this is formula applying. Here is example. We're going to identify the vertex of given parabola. First of all, we remember that x coordinate for parabola, we applying this formula, negative b over 2a. Also, we have to notice on this particular equation, coefficient b equals 16. A coefficient a, since it's nothing here, equals 1. We're going to plug in to the formula, and we found that x coordinate equals negative 8. Now we need to find y coordinate. Vertex has point, which is ordered pairs, x and y. So to find y, we just simply plug in to original equation, value of x equals negative 8. I did my work here. You can see, don't forget when you plug in negative 8 squared, don't forget to put in parentheses. So it gives big difference. So negative 8 squared is positive 64. So negative 8 times 16 gives us negative 128 and plus 64. And it's add up to 0. So the answer, vertex for this particular parabola, located at point negative 8 and 0. Here's another example. We're going to identify the vertex of that given parabola. Again, we notice that coefficient b equals 18 and coefficient a equals negative 1. So coordinate for x will giving us, so negative b would be negative 18. Divide by 2 times a times negative 1. And negative over negative positive, and we have x equals 9. To find y, we're going to plug in to original equation. For x equals 9, so we will have y equal negative 9 squared plus 18 times 9 minus 75 see if I have the room here. I can continue here. So we have negative 81 plus 18 times 9. I have 162 minus 75. And the final answer, I have 6. So the coordinate of vertex is x equals 9 and y equals 6. And we're done with this one. In this example, given graph of parabola, and we're going to identify some values for this parabola. First, they ask us to find axis of symmetry. Remember, parabola symmetrical over x-axis. So the line of symmetry, it's x equals 3. Go. So we're going to write down the axis of symmetry, x equals 3. The next, we need to find vertex. That point of parabola called vertex has 2 coordinates for x and for y. As we notice, x equals 3, y equals negative 2. We're going to write down 3 and negative 2 is an ordered pair of vertex. How many zeros? What is zeros, guys? Zeros, those points where it's parabola intercepting x-axis, those 2 points. If you notice, we have 2. How many zeros? Okay, 2 zeros, which are x. We have x1, I would notice it's 2, and x, the second 0 is 4. We answer this question. Domain. What is domain, guys? It is values of x where function exists, right? So if we see for x, we can scanning from negative infinity to positive infinity. We notice that for each point of x, the function exists. So in other words, all real numbers, that is our domain. I can write down, we can write down in interval notation from negative infinity to positive infinity. And range. Range, we understand that is all values of y that function have. So in this case, we kind of scanning vertically. As you see, my pencil goes up, like from negative infinity, up. Here is no function. From that point where is x equals, y equals negative 2, and up to infinity, that where is our range. So as a interval notation, we can write down, I put bracket, from negative 2 to infinity. So that bracket is, notice that the point negative 2 included to the range. With this example, we're going to practice how to graph quadratic function given in standard form. We're going to work on this particular one. Before we start graphing, we need to answer or find some values or take steps. First of all, we need to know what is zeros or roots of this function. So let me just work on this one. Find zeros. What does this mean? We need to find x-intercepts. Other words, we're going to equal given function where it's y equals 0. So we're writing this quadratic equation in standard form. Remember, we were studying solving quadratic equation by applying quadratic formula. I wrote down one more time for you to remind you. So x equals negative b plus minus square root of discriminant which is b squared minus 4ac divided by 2a. Just reminding you. Okay, and we're going to apply, very simple. But also we have to recognize what those coefficients, right? So a equals 1, b equals -2, and c equals -3. I wrote down for you, you can see it. And we're going to apply. So negative b gives us 2 plus minus square root b squared, 2 squared, 4, and then minus 4 times a, which is 1, I will not even writing, and times -3 under square root over 2a, 2 times 1 by 2. So I will continue. 2 plus minus. So as you see, 4, -4 times -3 gives us positive 12. Positive 12 and 4 is square root of 16, very beautiful number, over 2. And now we have 2 plus minus square root of 16, 4 over 2. We have two solutions. 2 plus 4, 6. 6 over 2, 3. 2 minus 4, -2. -2 over 2, -1. So we have two solutions. So we have x1 equals -1 and x2 equals 3. And we can fill it out. So we have zeros. We have -1 and 3. Now, we will talk about axis of symmetry, right? Remember axis of symmetry. To find line axis of symmetry, we have apply formula x equals -b over 2a, correct? In this case, let me, I can continue here. So x equals -b, it is opposite of -2 is 2, over 2a is 2. So we have x equals 1. So in other words, x equals 1 is our line of symmetry. Vertex, to find vertex, so for x coordinate we already know, x equals 1. To find y, to find y coordinate, we simply plug in to original equation for x equals 1, and we will have, so 1 squared 1 squared minus 2 times 1, 2, minus 3, or it is equals -4. So vertex located at point 1 and -4. So we answer this question. And now we're ready to graph this function. So first we start with axis of symmetry is x equals 1. So x equals 1. We can make that vertical line, axis of symmetry. So the vertex, remember we was found vertex at point 1, -4. 1, 2, 3, 4. So that is our vertex. Now we know that zeros we have at point -1 and 3. -1 and 3. Also we know y-intercept y-intercept, remember, it's equals -3. So that's another point. Line is symmetry. I'm sorry. Parabola is symmetry over axis of symmetry. So that point, symmetrical point, would be to away here. And we're pretty much ready to sketch the graph. It goes through the 0 x-axis, goes here, and that is our graph. So this is our parabola. I traces, draw it in the green. Next question we need to answer: does it has minimum or maximum? As you see, parabola opens up, so we have minimum point. We don't have maximum because it goes to infinity, but we have minimum point, which is minimum point. It's right here. So at point -4, right? Y equals -4. So we have minimum. Let me put just this minimum. And it is y equals -4, our minimum point. The last question we need to answer: what is domain and range? We was talking about that domain for any parabola, it's all real numbers. And range, remember, scanning vertically, and it starts at point -4 up to positive infinity. So we can write down -4 to infinity. And we finish this question.